Okay, so we're going to look at two more rules, the zero exponent rule and the negative exponent rule. So the zero exponent rule basically says that if you have any non-zero base raised to zero, it equals 1. So a to the 0 power is always equal to 1. So let's look at how that happens. Let's do x to the fourth over x to the fourth. So if we do it the long way, which we can, we would do x times x times x times x over x times x times x times x. So what happens here when we try to simplify? X cancels with x, x cancels with x, x cancels with x, x cancels with x. So what happens when everything cancels out? It leaves you with a 1. Now, look at what you had. You had an x to the fourth over the same x to the fourth. That is the typical rule that says a over a is always equal to 1 because anything divided by itself is going to yield you a 1. So here we go. If we use the shortcut, which says x to the fourth over x to the fourth would equal x to the 4 minus 4, we would end up with x to the 0. And so you get x to the 0 when you start introducing these rules. And so the outcome and the rule that must be applied is for you to understand that x to the 0 is going to equal 1. Because in order for you to yield a 0 exponent, it means the top is the same as the bottom. Okay? Then we have the negative exponent. So you should never have, a simplified answer will never contain a negative exponent. So a simplified answer should never contain a negative exponent. So it's like making your final answer an unsimplified fraction. Okay, so you should never have a final answer that contains a negative exponent. So anytime you have a negative exponent, a raised to the negative n, you would essentially rewrite it in its reciprocal form. So a to the negative n is automatically equal to 1 over a to the n. Okay? All right. So how does this occur? Let's look at um, x to the fourth over x to the seventh. Okay? So x to the fourth over x to the seventh. So when we do it the long way, we get x times x times x times x over x times x times x times x times x times x times x. Okay, so we would start canceling, cancel, 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 cancel. So what happens here? Everything canceled at the top. So what do? We hold that with a 1 over what's left at the bottom. 1, 2, 3 x's, which would be written as x to the third. Okay, so we get 1 over x to the third when we simplify it, just doing the expanded form. Now, if we were to apply the quotient rule, because it's division, right? Quotient, divide. So if we were to do the quotient rule, we have x to the fourth over x to the seventh. And so the quotient rule says that you subtract. So you have the top exponent minus the bottom exponent. So when we do that, we get x to the negative 3. Okay, now, remember the rules are shortcuts from the original method. The original method got us 1 over x to the third power. The shortcut gives us x to the negative 3. Well, we know this one is the correct one because that is the expanded form. This is a shortcut where we have this x to the negative third power, which is why the negative exponent rule is important, because essentially if you work the problem in its expanded form, which is just using the definition of an exponent and then simplifying, you would not yield the negative exponent, you would just yield the fraction. And so in order for you to be introduced to the negative exponent, it is a result of the shortcut. So when you have that negative exponent, you must rewrite the problem and rewrite it in its reciprocal form. So x to the negative 3 must be written as 1 over x to the third power, which is how you would then get the same answer. So anytime you have a negative exponent in a problem, you must imply and use the negative exponent rule and rewrite it in its reciprocal form. So because of this rule, you're just going to have problems that just automatically give you a problem that has a negative exponent. So the only thing you have to do here is rewrite this as a positive exponent. Okay. Also, you may be given a problem where the negative exponent is already in the denominator. So anywhere you see the negative exponent and its base, you would have to just rewrite it in its reciprocal form. So if it starts in the denominator, its reciprocal form would be the numerator. And that's it. It would be x to the third over 1, which is then just x to the third. Okay? And those are zero exponent rule and negative